Bad idea.
So, the northern lights, they're ionized air particles that got hit by radiation and they turn into plasma. All right? Everybody wants to see plasma. We want to quit talking about it. So what we're going to do, shut off the lights a little bit and pull some shades just for the entertainment of it. So basically we're making, so the plasma that you get in the northern lights is ionized.
Can you pull that down?
That's fine.
There's a light on that. There's a light. You
Can you turn that off?
Yeah, there's a light there.
The main light is coming from that right there. We can't do anything about that. So
Where's your black?
the ionization from it's some air molecules that get hit, blasted by radiation. So we can't do that.
If we all die, it's
Unfortunately.
your fault.
Okay, I'll take responsibility. The thing we can do though is we can ionize aluminum and then blast radiation at it, and that's exactly what we're going to do now. You can come up here and look through the door if you wish, because it's a little bit hard to see exactly what's going on.
This is gonna be our last minute. Straight. Nothing's happening yet. Whoa, there's Mars.
I'll stand beside
Look,
you.
plasma
I
can't
see anything.
Is it on fire?
Nothing's happening right now.
Okay, it needs to heat up. Okay. Not enough radiation.
Maybe I need to
No, the other one had a little hole on it. Christopher, it's gonna blow
I'm
up.
going to grab one more tin foil.
Mr. Penn,
No,
the
someone
other one
grab
has a
some.
hole in it. I think that
That's
that's
good.
Oh, it kind of stinks.
Yeah.
Sometimes
Where
I
does
feel
that
like
stink?
Well, like it's like a little bit.
If also we may have damage
It
to
did.
the microwave, you never
Because
know.
he realized.
This is not very hot. Which is good, that's fine. Alright.
Okay.
You started over.
No, we're good.
Oh, I can't see.
There you go. So now it starts floating up to the top. When it floats up to the top of the jar, that's the
Oh, it's
plasma.
blue.
I can't see anything.
Oh,
I'm
that's
seeing
nice.
wires.
So you shut it off for a second.
Oh,
Alright, so
Burning.
what happens is it sparks.
Ow, you just cracked your grass.
Nasty! Now I'm all offended. Alright, I have another thing here. I have the Pyrex piece. So what happens
Keeps
is,
it hot.
That's very warm. So what happens is the spark happens, and that's when the ionization happens of the aluminum. And then there's kind of that flangy, weird
I
thing
just
going on.
see a lot of
That's the
sparks.
plasma. When the stuff goes up to the top of the jar and floats there and sparkles for a little bit, that's the plasma we're looking at. That's like what the northern lights
You're
is.
gonna. Okay, so
There's
here's
a
the
mask.
picture. There's not a lot of tinfoil.
I can't really see anything.
Well,
I just see the
it's got to
sparkles.
look a little bit, and it's just the way it is for now.
Your
There's
thing
the
isn't
sparkle.
even in the trash. Listen, why don't you just damage the microwave? I mean, like, no one's
Well,
gonna
because-
use this microwave.
Yeah, let's just let it sit on there for like a long time.
Because no, I have other plans for microwave if we don't have to. All right, so let's go ahead and start it up again. See if you can see that stuff floating
Yeah,
on the top.
I see the stuff doing it. Oh, there we go. Oh, I will.
Sounds like
so-
yeah.
It's burning my eyes.
Sounds like a grinder.
Oh.
Oh,
There, you saw that? You saw that
Yeah.
stuff go up to the top?
Yeah.
That's the plasma. That's like what the northern lights
Man,
are.
that stinks.
It's good for you. No, it's not. Not even close.
It smells like the shop. We like
Are we gonna pass out?
get air in here.
Yeah, we should just get a little bit of air in there.
Oh, that smells like.
Is it like?
And it actually burns the edges.
Is it hot?
No, not anymore. It was pretty warm for a while. Hey, gentlemen! Don't go far into the fresh air. We have something else to do. All right.
That should be like that.
So, that's the thing first of all right? So that's plasma. That's your Northern Lights demonstration.
But that didn't look like the Northern Lights though.
Well, that's because we only had a little bit of it. We had to contain it in a jar.
Well, it did. It's the right color.
Yeah, it was the right colors.
So God just sends lots of tinfoil down the microwaves.
Well, he uses air atoms and ionizes those rather than sparklate the aluminum. He sparkles on. I'm not sure which atoms it is. Is it oxygen possibly? I'm not sure. One way or the other. He uses a different kind of different kind of attitude.
All
All right.
Nothing like top 10 years of my life.
It's actually a pretty day outside.
Can we work outside?
Yeah, there we go.
It wasn't.
Is that a mask?
Uh-oh.
Is that a mask?
No, it's bubble wrap.
Oh, no.
No,
Wrapping
I
paper.
didn't really
It's wrapping.
Wrapping tape.
This is the other thing.
Is it, what is it? It's a parachute.
Oh!
Is it like those
Right.
lanterns?
No, I made this
Those are
up.
cool though. It's
The
just
last
like-
time I did this, it did start on fire. Just as a lot, that's side note.
Cool.
All right. So what we have, we're talking also about air today. We're talking a little bit about hot air rising. It kind of goes into tomorrow, but I'm like, hey, whatever. We're doing determinants today. I got all the stuff. Here we go.
Did it start?
Oh, why?
If it starts on fire, we're prepared. So what?
What do you use that lighter for?
No,
Those are
Geneva.
gonna blow away.
It's not outside.
It doesn't work.
Better
outside.
than burning the classroom.
We can freeze in our room.
They work. They're working.
There's a whole thing. Where's my matchbook?
So this is
It's
simply
on the desk.
a demonstration of hot air
Oh,
rising,
yes. My science book.
which you all know how that works, but sometimes it's fun to see an actual visual. Unfortunately, this candle went out and I can't relight it.
Oh.
I hope 4 is enough. 3 is
I'll have
not.
Miss Andrea just get a whole bunch of candles.
Don't you have a computer lighter? Well,
It's
I'm
all
sure
light.
that, yes, you can, I'm sure the other teachers have cameras.
Yeah.
Be willing to let you.
We'll see if 4 works. If it doesn't, then
Dude, Mr. Walter has that big one sitting in his room that has like the big one.
Oh, yeah. I'm not
That
sure-
thing would do it.
It's supposed to.
The crackle one.
All
It's
right.
gonna float over top of it.
So
Versus-
the principle is, of course, hot air rises, and we understand that.
Hopefully it starts on fire.
And so what we're doing is we're trying to capture some of this hot air and watch it rise.
And then it starts on fire, can you clap?
Yeah.
Clap and cheer.
Oh, that's good.
Did you make sure you covered all? the
Experiments are
holes?
always better with fire.
Yes.
And what? And when
Well, that's
they
my
fail.
theory as well.
And when they fail, too.
Okay.
That seems like it would start on fire.
It will if you're not careful.
Oh, starting on fire is
Normally it starts on fire once it starts to raise and then drifts over the edge of the fire. Over the edge of the candles.
I'm seeing something happening here. Does it? Well,
You see it filling up.
If you let go, well, it does.
Okay, so now it's standing.
Oh no, the fire.
Close the window.
Yeah, we need to get rid of some of this breezy air.
Everybody close the window and sweat.
Here, come on.
So
Get
it
some.
wasn't-
Go up. Oh, it's just falling over now.
Start on fire, please.
Okay.
Pretty.
Let me go see if Mr. Walter has a big candle we can use. Thank you. I should just have a massive Bunsen burner. So that would be much more dangerous.
That'd be cool, especially inside.
That would be much more dangerous, but honor.
You really could choose that little.
Fire is good. I mean,
Fire is
honestly,
awesome.
Fire
if there's
is
one way to
marshmallow.
spice up a school day,
Fire and
Yes.
explosions.
And explosions.
Mhm.
Explosion.
That's true.
Did we have any explosions?
Not today. Well, I guess small ones.
We could make an omelet.
No, Amish bombs are stupid.
Now we should make one.
They're wimpy and terrible. And
Okay,
We'll
well.
make a bigger one. Hey, this is all he has.
Can you get a little bit of fire out of it?
I don't know. Hopefully.
That wick's pretty burned out.
Goodness. You could ask Miss Amy if she has a candle. Did you ask all the teachers?
Just Miss Andrea.
Miss Heather has one.
See if-
Just
see if we can
Miss
get one more.
Andrea?
Go and be my.
Yes.
She has
Heather, she
5
has extra.
candles?
I had 2.
You know how you could.
3. That's still a lot.
She was well situated. Yeah, this is a. I would say it's seen better days.
Candles are this wonderful.
Okay.
She probably got them. Yeah.
Whoa.
She throw them
Oh
all.
no, we just lost our hot.
Well, kind of.
Oh, yeah, it's
I'm
starting
pretty
on
sure you still
fire.
have some left.
Thing is never going to start on fire.
I hope
Thank
it
you, Miss
does.
Heather. You're such a
Oh,
child.
yes.
Oh,
Yeah.
here we go.
Put them all together, put them
Yes, we will do all the things.
Watch the hole in the ceiling. Let's start
No,
a bonfire
yeah,
and
the
hold it
black
up in the
spot on
bank.
the ceiling.
Don't forget,
Hey, Mr. Cat, bring the table over the fire.
we are not afraid that his house is burning.
Yes, I got 3.
You got 3 marshmallows before for the fire.
That's for the white
People
one.
will
This is
stand
for
back 300 feet.
this one.
I've been trying to throw marshmallows and do something to get the fire out.
He's sitting there roasting marshmallows.
Okay, we got
It
some
was
good
at
ones.
wit's end.
Well, you already know this.
Yeah, but this one actually.
Well, Mr. Whitaker is going to be so sad about the petunia bushes.
Can you reach in? No, you can't.
I don't know.
Yeehaw!
Oh, Mom has a really tiny candle like that.
This one they're annoying. Owie.
Mom,
Alright,
And virtually.
Mr.
I
Kennedy,
know.
these are his matches.
I don't care.
I like matches.
I don't like
Lighters
matches.
are smart. I mean, matches are
Alright.
fun.
I like those gas
Those are the fun.
Here
Those are
we
supposed to be
go.
way-
Matches are funner because they get the stripe anywhere. Dad just takes matches and then strikes it on his pants.
Like, you get
like
Mr. Kent, this doesn't start a fire in the first try. What if he accidentally lit himself?
It's trying to go up.
I see
Come on,
smoke.
light on fire.
Oh no, I don't.
Too much tape.
Too much
It might
candle.
be too much weight. No, if nothing, if anything else, we need more heat.
Put your lighter under there too.
Just sitting here and carefully balancing. Come on, go up.
3 more candles.
How did
But what should we name it? Christ in it.
Frederick.
No go.
No go. Stop. Christ in it, no go.
We'll call it.
Come on. Give
Don't
me some
they
altitude. Oh yeah. Yep, come on. Come on. We got something. Possibly.
Need some more.
Come on, Mr.
encouragement.
Kent's third favorite son.
Yeah.
Need some more
Name
encouragement.
yourself. Come on.
Christmas
Come on.
presents always help.
And if you give one to him, we'll feel left out. So,
It is light. It is definitely lighter than it was, but it is not elevated.
Then just light it on
Aha.
fire.
Let's not
Uh-huh.
You know there are matches around this joint?
You know, do you ever try lighting, opening a tea bag and lighting
Go
it?
check Miss Amy. See if Miss Amy has.
we should just start a fire, like a fire.
Did you ever try, Richard, did I show you how to light up? You just light
Well,
a
that's a
tea
pretty
bag?
big
You
flame
open it
fire.
up.
Yeah.
You just light that.
No.
Mr. Kent, could you just
Go
light
up.
the bottom and
Oh,
then
it's
let
already
it go
up.
up?
Okay, you said it.
Like a tea bag. Mr. Kent.
Yeah.
Oh, you never put the price in. Mr. Kent,
Ah,
how
This
much
is
do a
taking
tea
all the
bag?
candles in the house.
We asked everybody.
Well,
You have to take a trip to
Ask
the
Miss
store.
Amy.
I did.
That's Miss Amy. That one doesn't work.
Laura
That's
Storm.
Mr. Walter.
Well,
Hang on,
let's
I
go
got it.
buy Laura out of candles. Yeah, there we go. Just to get this.
It's like $8 a candle.
I think
No.
That's coming out of his pocket.
Oh,
No, 12 ounces, 16.
I don't even know.
Come on.
I barely
I feel like I-
You know what you could do is just put
That one's-
wood inside.
Yeah, basically
Put a
it's
wick-
an alcohol burner at this point. Which we could make one of those as well, but I'll show you.
Is
Why don't we just go
how-
outside and start a fire?
Yeah,
Or stick it over top.
Sorry.
Just light it on fire. Mr. Kent, you know that tea bag trick where you
Truth of the
light
matter
the
is,
tea
if
bag
you lit it
on fire?
it would go up.
Yeah, see that's right. The tea bag, like, we light it on fire and it goes up. Just do that with that.
so fun.
I just really
Our
don't-
neighbor
don't
did it
really
catch
actually
up
wish
first
for it
time.
to light on fire.
Why?
Yes.
We could do it out. No, no one work outside.
It would not work outside very well.
Well, if you have some tea bags, you could just do it on a
I
way
have all
smaller
that
scale.
tape on the top and put like scotch tape or something.
Why don't you just open up the top?
Because then we let our heat up.
And then we could warm it.
Come here. Go up. See?
Go, lightsabers, or see. Go.
Will this one work?
Oh.
Oh, I mean, whatever. We
Dump
have-
some wax out.
No, this is not my candle. Unfortunately, I can't defile it.
That's not defiling it, saving.
Why are you burning it before?
I was just running before I didn't have a way to get my fat little fingers down in here, right?
Well,
Yeah.
is it the wax? What?
The wick is bent down.
Dump some wax out. All I'm
Okay,
doing
so here's what we're gonna
Yeah.
Well,
Then it coats it.
those ones don't coat.
We're gonna take this
From
outside
ours where
briefly.
they
I think we
don't.
can probably pull this off.
Are we gonna light it on fire and watch it go
Yes,
up?
we're going to light it.
Yeah.
Alright.
Then
Yeah.
let's
So
go
I
fun.
was, Cody, you on the other end of this table, somebody can do it for me?
I don't know. I never get manual labor here.
Well, you're gonna get good. This is the direction we're going.
Hey, you need a fire extinguisher?
Nope,
No,
we already don't need it.
Guys, this is not news.
No, just leave it inside, kid.
Wow, it smells good.
Yeah.
Like a scented.
That was boring. Alright, what it was.
That was a good one. Turn it out.
Where's the lighter at? I want one.
Alright, you can't all be winners. Unfortunately, I lost that one.
I'll have to try it tomorrow.
But
There was no winner.
I have another plan for a different type of demonstration for heat, but we all understand that heat is supposed to go up. That's good.
Oh, it did.
All right.
So.
We didn't have to use that fire extinguisher.
I know, isn't
Put
that terrible?
helium in that.
Ridiculous. Alright, so here's what we're going to start with.
Dude, we'd have a bomb.
And put oxygen, half oxygen,
Nuclear
half.
weapons.
Alright, now we're basically on time, so now we have to hurry. We're going to check this out, the review sheet I gave you.
Oh, no.
Do you find that? You should find that. 7.2 reviews. Alright. So, obviously there's no exosphere in number 1, but that's fine. So 1 is troposphere, 2 is stratosphere, 3 mesosphere, and 4 thermosphere. Number 2 is mesopods. Number 3, UVC, and circle is. It is entirely blocked. Number 4 is mesosphere. 5 is thermosphere. 6, UVA, UVB, UVC. 7 is nitrogen. 8 is 14.7 pounds per square inch. Number 1, on the next part, radiation. 2, sun. 3, insolation. Make sure you spell insolation S-O-L. Insolation you find in your walls is S-U-L. That's different. And then the next 3, clouds, length of day, angle of sun's rays. We didn't touch on some of the other things.
I have daytime clouds in the sea.
And 5, low and high in that order.
What? You said low and
High.
Oh,
Low of the-
That's wrong.
No.
I'm pretty sure
That's
that's
right. I was reading that wrong. Black card is high albedo, so it's high.
Yeah, I was
and
trying
high.
to figure that out. I was like,
Wonderful. My
Wonderful.
bad. high and low. That's correct.
If I read it, that's what I have because that's what it says in the book.
Really?
Yeah, it said it, it did too, it said it in the
I
second
found
one.
it actually.
It says-
This is the
I
first time
honestly,
I
I
found
didn't even see this demonstration. I didn't see what they were asking for.
It said it in
I
your
made
black
that
has a
all
low
up.
albedo, while white has a high. Yes, it does.
Where
Yes,
is
it
it
is.
talking about albedo?
You're right here, I have it.
What page?
Yeah, it says right
Okay.
here, albedo, because white objects
Albedo.
reflect the
Albedo.
association. They
White
have-
objects have the highest albedos, yes.
Whatever.
Black car has low albedo, while a white car has high albedo. So albedo is, I was right. I got that.
Now
Who
you
can see
are.
that? Yes, it was. A white car has the
Ranges.
highest albedo.
No.
Black
What
objects.
does that mean? Resistance to the sun?
So is it just wrong if you have
No,
0
wait.
and 1?
No. Hang on.
Because we did.
A
Black
white-
car gets
A
longer
white object,
faster.
a white
And
object has an
non-
albedo of 1, which is as high as you can go. White is as high as you can go. Black, that does not reflect anything, has an albedo of 0. So the less it reflects, the lower the albedo is. So black has low, white has high.
Yeah, how come black?
So is it wrong if you wrote 0 and 1?
Yeah, 0 and 1, I can give that to you. But right in behind that, low and high.
I know, what's wrong?
Ah,
Not too long.
I
That's
always
what
not count any of that wrong
Hang on.
because of confusion.
Yeah, no, we're not
No.
wrong.
count it wrong. If it's wrong, it's wrong. You were confused. That's the only person who's confused. 8, at least the beginning.
Nuh-uh.
9, 10, 11, 12, 13, I forget how many I had, 14, 15, 16 questions. So they were approximately, called worth 7.5 points apiece. So 2 wrong is 15 points.
One wrong.
2 wrong
is
is
seven.
15. Okay, so
I just got a 93. That's
So if we got those switched, is that just 1 point?
what?
I counted as 1 whole point.
So I have to figure on that's
That would be 21 points off, so 79. Alright, say 1 off would be comments. Hey, I need your grades as well. It's crumbling.
Trouble like this.
Hey, Chris, bring that up.
Do I have anything like
Cody, bring yours out as well.
Oh.
Thank you.
I am running just in a big ball. And you
Nope,
know that.
unfortunately, that's
it's a
not
surprise.
Yeah, it's a surprise.
That's not acceptable. All right.
Surprise. A couple things.
Good. Here we are.
Wow.
Yeah.
Space of 30 seconds.
What happened?
All right.
If I can prove it.
The most important thing we have going on today. We're talking about greenhouse gases.
Oh, greenhouse gas.
Greenhouse gases are actually a thing.
Are they the things that are heating us up?
Well, what they do is they act
Greenhouse
as.
gases.
All right, that's enough. What greenhouse gases do? Have you ever been in a greenhouse? What is interesting about a greenhouse, even in the winter?
They're hot.
Yes. Why are they hot?
Because mom eats it.
True. What else are they hot?
Because
Because they're designed for that.
They're designed to stay warm. That's correct. What happens is, you have your greenhouse. This is looking at the end of it. You have sunshine. Sun shines right through the plastic on the outside.
The yucky green plastic.
Say what?
Yucky green plastic.
Well, not necessarily. But yes, could be.
Can. I've seen
All
green.
right, that's enough talking from me. I don't have time to talk to you. We'll talk over to this one. So that's enough. We're out of time. So the deal is, basically, when the sun shines in, it puts heat inside the greenhouse, right? It shines on things, plants are green, there's stuff in here that warms it up. The plastic keeps, the plastic keeps the heat inside, right? And greenhouse gases do similar things. So basically, greenhouse gases just cover the earth in a blanket. The sun can shine in through the greenhouse gases, and the greenhouse gases just simply hold that heat in close to the earth to make it so that things stay warm. So that's what a greenhouse gas is. Greenhouse gases, well, first of all, the most important greenhouse gas is water. There's water vapor in the air. That's one of the things that affects how much the atmosphere retains its heat. And that's why here in the desert, very often it changes really quickly. As soon as the sun goes down, it gets cold, right? And that's because there's not very much water vapor in the air. So the water vapor is acting like that greenhouse and holding that heat into us, except for when we don't have it and it doesn't. So that's why we get big variations in heat. Trying to decide what the most important things to talk about. What do you call solar energy that reaches the earth?
Insulation.
Insulation, thank you. All right, next thing is convection. Convection versus conduction. And that is kind of the last thing we're going to talk about right now today. Because we'll be able to pull out this quiz. That'll be fun.
So we're supposed to do 7.2.
Hang on. I thought I'd give you like a second. All right. Convection versus conduction. I need my fire again, so I'll make it.
Is that stuff that's sticking up back?
Yeah, this is a much taller candle one day. My wife gave it to me because it was completely shot.
Can you make me more shot?
No, I'm afraid not. But something to talk to you about. If you hold your hand above a candle, or above anything that's warm, what you feel is the warm air currents rising up off that candle. Anything that's warmed by something blowing past it is warmed by convection. I'm sure you've heard of convection ovens.
Yes, you can.
Probably. That is when there's a fan that moves the air around inside the oven. Right? So when you hold your hand up here, that air moves up, creates a stream of warm air, and that is convection. If, however, I were to take this candle, which I won't, and set it right on top of that flame, this candle would be warmed by something else, something called conduction. And what that is a direct heat transfer between things. So say, for example, an egg in a skillet is a great example of something being warmed by conduction. The heat is passed directly through the metal into the egg, right? That's conduction. But if it's air or liquid, and it's swirling around, like if you put something in boiling water, say, for example, you're boiling an egg in water, so we're going to make a little thing here, and we have our fire under here. Ooh, that's a good fire. Here's our egg, here's our water. So the deal is, water here is warmed by conduction, right? That means that the water is warmed by the fire warming up the pan, and once the pan is warmed, it warms up the water. So that's conduction. The water is warmed by conduction. The egg is warmed by convection. And that means that the hot water swirls around the egg and warms it up and boils it. So if it's not being warmed by sitting in a liquid, it's being warmed by conduction. If it is being warmed by something moving around, it's called convection. And we're going to talk about more of those things later, but you have enough information at this point to do the assignment for today, which I want you to do 7.2, 1 through 6, and this quiz is a worksheet. And I need to make a few copies of this quiz.
So,
Yeah.
Mr. Ken,
Yes.
if that candle was in the oven and you didn't have, you had a bunch of candles in the oven and you didn't have the fan on, would it burn stuff more? Or
just bake them harder?
What are you burning? What are you baking?
A cake or two.
If you don't turn, basically it's just the method that things get warmed up, right? So if they aren't in direct contact with something hard like a pan, like if your cookie sheet is right over this flame, to where the cookie sheet directly is being warmed by the flame, which of course bakes your cookies, that would be conduction, because the heat is being conducted right through the bottom of the pan. However, if it's a distance away and it's just the air, you're warming up the air in the oven, right? Then you're cooking your cookies by convection.
So, Mr. Kent, I have another question. So say you have cold air, right,
Yes.
on above my or hot air below my pen, and I take away the pen, what will happen? Like, they both try to go past each other, but can't wind them go in one direction at once?
Wind?
Yeah, because they'll make wind going up. Like, the hot air will try to rise and the cold air will try to go down.
Basically what happens is hot air is always more powerful than cold air. Hot air pushes cold air out of the way. That's
It's
a
like
simple explanation.
In winter,
All right, Martin, I'm going to make a copy of this. You can follow me out this direction, and I'll do this. Got 2 marks in the
He didn't answer my question.
I wanted Our attic in the winter, if you open the attic door, all the cold tanks come down, all the hotter tanks go up, and it just feels like you're in a whirlpool. But I don't know what you're filling up with.
So, Richard, what's number one? Which kind of heat transfers involves electromagnetic waves? Radiation, right?
Yeah, I hate radiation.
January?
It's 7.2, right?
Is it January?
Name three factors that affect the amount of insulation of the roof.
Yes, it is.
Where is my other key?
This can't tell you.
It helps me. It gives me answers for the left hand.
I have no idea what